Hello, everyone. My name is Sérgio Ferraza. Today we present my undergraduate thesis titled Analysis of the Thermal Energy Performance of the Buildings of Pampa Scientific and Technological Park, Pampatec, through simulation with Energyplus software. We focus on the results of the right building. Energy efficiency has become a topic that was currently being discussed because of the deficiencies in the generation and distribution systems and the recurrent increase in the energy tariffs. Uh, in 2014, the Logistics and Technologies Secretary published a normative 2, making the construction and renovation of public buildings conditional on obtaining energy efficiency certification, S.A.F. So Pampatec is a public building, which passed through several stages until its conception, a process that took a few years. However, the initial project in 2010 had no major changes until its inauguration in 2015. Pampatec, aqui we show the photos that buildings. Problem definition. The following issues have been identified in the Pampatec. Incorrect sizing of refrigeration equipment. Large area of glazed facade made up of simple glass. High internal temperature, resulting in discomfort for users. Objectives. The general objective of the work is assess the thermal energy performance of Pampatec, and specifics assess the thermal energy, assess the current condition of the buildings, propose efficient physical and or structural improvements, select equipment that meet the cooling power demand of each room, keeping the same cooling system split. Theory. Thermal comfort can be defined according to ASHRAE 2010 as condition in which the mind express satisfaction with the thermal environment, where have thermal balance between body and environment, and body represent low sweating. Methodology. The building was divided in independent thermal zones with the help of Google SketchUp software as shown below. A thermal zone is defined as a single air control volume with homogeneous temperature. The Energyplus software simulates the interaction of all thermal variables that influence the thermal zone, considering all forms of heat transfer involved: radiation, conduction, and convection. Solar position. Here we see the building solar position. In the right, we can see the building study. The thermal zoning was done according to the building project, considering each room as a one thermal zone. Thermal loading. The thermal loading consists of heat added to the air control volume, like electrical equipments, lighting, and occupation. Here we can see the values obtained for each component of the thermal load for their respective thermal zones. Simulations. Simulations with three main focus were carried out. Simulations without changes, were addressing the automatic sizing, auto size, of the refrigeration system and using currently installed machines without any improvement. Simulation with suggestions for improvements. Films, where four films configurations applied on the glasses were simulated using automatic size, auto size. LED lighting, simulation of best film condition replacing current lighting with LED light in auto size mode. And simulation with select machines, simulation of the final suggestions for improvement with the appropriate commercial equipment to ensure thermal comfort in all thermal zones. Cooling power demand. The graphic shows the percent difference between the actual demand for cooling power and the installed power in each thermal zone. Suggestions films. The reduction in cooling power demand was 26%, considering the current auto size basis. Suggestions LED lighting. The increment of LED light at the suggestions of better film increases the percentage of reduction in refrigerant demand from 26 to 30.3%. Selected machines. The table shows the cooling demand in each thermal zone and the respective cooling power of the selected machines. Monthly energy consumption. So the graph shows the monthly energy consumption reduction between the current state and the suggestions to improve the use of films plus LED light. The average reduction was 29.5% in electricity consumption for cooling, 59.8% for the lighting system, and 18.4% on the building's total consumption, as seen by the solid black line and the dashed line. So, conclusion. The study proved that the suggestions for improvement, together with the correct selections of machines, can keep the temperature as 24.5 degrees Celsius in all thermal zones and provide a reduction in the consumption of electricity for the building. So that's it. Thank you